Well, gang, we know that we've got a lot of different types of ports that are available on a converged switch that are going to be used to support access points and then also support working our way out through the distribution layer and onto other parts of our network. So in our CLI or in the graphical interface, we're going to have tools to make those things reality, right? To define our world, define our environment. So one of those key things that we're going to need to do early on is, of course, define our VLANs. Now, in the client configuration, the CLI, it's very easy, VLAN 11. Here in the graphical interface, you would select your VLAN environment and click New, and you can build out a new VLAN. When we look at our port configuration, again, we can see that our ports are assigned as trunk ports and or actually, I should just say or. It'll either be a trunk port or it will function as an access port. And if it's an access port, then it's providing support for an end user device, right? For a client. Now, how do I create that association for our access ports? Well, that's going to be pretty straightforward. We'll do something like this. Here we have interface. We're using gig 1/0/3, switch port access VLAN 11, and then switch port mode access. So again, this gets us into the interface context. We're defining the VLAN that it belongs to and telling it, yes, use it. You're in access mode, not a trunk mode. So use VLAN, use the VLAN 11 access port to support your device, like the switch that'll be connected, or sorry, like the access point that'll be connected to here. Now, that access point is probably going to want to be able to route out as necessary of this network and be able to work with that. So how do I provide an interface to coordinate with that behavior? Well, remember, that's defining an SVI, a switch virtual interface, interface VLAN 11, and then you give it an IP address, and don't forget, no shutdown, so that it will actually execute and run. All right, so that defines that world. And then, well, you need to be able to support, I mean, you don't have to statically configure those access points, right? So for that, how about IP DHCP pool management, network 192.168.11.0 with 222.550 subnet mask and the default router of the SVI to be able to get off of this device if necessary. So that is going to be what provides the IP addresses for that particular pool, in this case for the access points. Now, you can also run this same command instead of commands, define a VLAN and define the SVI and define the DHCP pools for your clients as well, for VLAN 14, as we might see here, a client VLAN. Same process that you would use in that configuration in order to manage that. So let's take a look as we're continuing to look here in the web environment. Now, when we create a wireless LAN, all right, when we create a wireless LAN, it'll have an SSID. And with the iOS XE, we also have an ID number assigned to that. Now that ID number is then going to be bound to a VLAN ID number. That's a very close association. It's different than in AirOS, where the wireless LAN was associated with an interface. Now the wireless LAN is associated with a VLAN, which makes it much more flexible. So our access points are going to be connected to our switch ports. And they are going to be, and that switch port is going to be assigned and a management IP address, like over here in range 11. But then the clients are going to be assigned a VLAN that, again, allows them egress. Now, to make this work, once again, we would need a VLAN 14. We would need an interface, an SVI for VLAN 14. We would need to use a DHCP pool for VLAN 14 in order to be able to support that. Or if we're not locally defining DHCP, then we use a DHCP helper, which is also in our configuration for any of these LANs. All right, and also notice as we're looking at our wireless LAN configuration here, we can see configuration for a particular access point that's connected. We can see the properties that are moving on here, what channel it's running at, power levels, all these things showing us the access point that's available. And then when we look at the port configuration, we can see, okay, this guy's been configured. There he is on port 11, configured to work in this converged mode as an access point, right? That's exactly what we had in mind. And then VLAN 11 here, notice this is the wireless interface VLAN 11. And then we saw over here, again using VLAN 11 in our wireless controller configuration. Here's the thing to keep in mind about kind of you actually have some options here. I've got an access point and it's connected to this switch, which is also, remember, a wireless LAN controller. So I've configured it. I have this wireless interface that is associated with a particular VLAN. In this case, it's 11. If I configure the access point for VLAN 11, then this will be a CAPWAP termination point, and it will run in converged mode. Yay, that's what I had in mind. But what if, for example, I had an access point and I connected that access point and I plugged that into an interface and I assigned that interface VLAN 12. What happens in that mode? In that mode, it will function like any other set of data moving in VLAN 12. So if it's an autonomous access point in VLAN 12, then the client traffic leaves out VLAN 12, right? If it is establishing a CAPWAP tunnel to a wireless LAN controller that can be discovered on the network that's beyond there, then because I'm not using the wireless interface VLAN, now this access point can find a remote wireless LAN controller. So if I need to keep it consistent with a different environment, I can do so and I can discover that because it's not using the wireless interface VLAN. But if you want it to be the same, converged mode access, it must match. The access point VLAN must match the wireless interface VLAN and of course have appropriate network IP schemes that are going to function and work correctly. Last thing, gang, in our switches, we have the ability to configure link aggregation. And remember those uplink ports, those 10 gig uplink ports? Yeah, this is a great way to use them. So we're talking about a 3650 or 3850 over here on the right-hand side, and those are connected directly to our access points. This is an access layer switch. What about the distribution layer? Hey, how about I configure 2 ports to each of my distribution layer switches, our 3750s operating right here. These are our layer 3 switches as well. This is where we're configuring, in many cases, most of our rules and policies, right, at a central level. 3850, we can double that and do link aggregation of up to 4 ports each. And remember, if we're using PAGP, if I wanted to, I could configure, all of these local to one device. I've got a lot of options available to me. Now, on the left-hand side here, we're seeing this change of mode here. In this case, we have our access switches, our distribution switches, and our centralized 5760. In that case, it has 6 of our 10 gigabit ports, and so essentially you can see we can have link aggregation working downstream to the distribution switches, whether this is a mobility controller, and actually these are 3650s and 3680s running there, running as mobility agents. That's one way to operate it. Or I could be just running this in a centralized mode, in which case our access points are actually building CAPWAP tunnels all the way up to that 5760 kind of sitting at the top of the heap there. And again, when they do that, the content works its way up through here and then exits using some pretty high speed capabilities, right? I've got a 60 gigabit exit point for all my wireless traffic, leaving out those CAPWAP tunnels. So very powerful point of egress. All right, just something else to think about in terms of the switch aspect of our devices.